Okay, so we're going to look at some application problems in which you're going to be writing the equations again. And the important part is to recognize what you're given. So they're either going to give you the slope, the y-intercept. Rarely do they give you an x-intercept, so it's usually either 2 points or the slope and the y-intercept. So let me give you a few pointers on things. If they are talking about the y-intercept, they're usually going to talk about something about it starting at or beginning. There's something referring to where it's starting or beginning. That's going to be always your y-intercept. And so that would be your 0, your y-intercept. Your slope, they didn't leave me enough room here. Your slope, guys, is going to be, again, it's rise over run, so it is usually a rate, okay? So what I mean by that is like miles per hour, okay? Dollars per hour, okay? Feet per second. Those are things that are rates, okay? So that's how you're going to identify which is your slope. So when I come to this first equation, here it says a cab ride cost $4, plus we're going to add to it $1.75 for every mile, okay? So again, that cab ride costs $4. That's kind of your beginning. That's like what we would call a flat rate, okay? It's going to be $4 no matter what. So that's your beginning. And then it's $1.75 per mile. So again, that would be your slope. So when you write your equation here, your $4 again is your y-intercept. So if I go to y equals mx plus b, your y-intercept again is 4. And I'm going to give me a little bit more room here. And $1.75 per mile. So I'm going to do $1.75 x plus 4. Now, the other thing too is, especially as we get to progressing through these, I would really like, if possible, to use variables that pertain to the problem even. So in this case, we might say the cost is $4 plus $1.75 for every mile, okay? Now, that's another way. And again, you flip it around. Yeah, it's not in slope-intercept form, but I just wanted you to see what I'm talking about. The other thing, guys, is you're going to see it in function notation, okay? And function notation would be the cost given the number of miles, and then 4 plus 1 plus 7.5 m. And again, when you do function notation, whatever is here is what's letter is in your equation. And so that would be the cost given the number of miles. That's what that would mean, okay? And I personally think if you're doing a story problem, that makes a lot more sense than y equals and x, okay? That's me. But again, we'll talk more about that as we progress and we do more problems. So let's look at the next one and see what it gives us. If Clay's destination is 17 miles away and he has $30, will he make it? So that's referring back to A. And so it is saying 17 miles. And in this case, and I'm going to kind of go back to what we were doing. In this case that we're doing on this problem, okay, let's just talk about what is my x and my y. And when I put the variables in there, hopefully you realize that my x, I'm relating here, this to here is miles, and my cost is my y. Okay, so just relating those two. So when I come over here, I'm really looking at the point 1730. 17 miles cost $30. Okay? And so the question is, will he make it? Okay? So, and it doesn't matter which way you do it. So if I put in my 17 miles, okay? What I'm really wanting to know, will that equal 30 or greater than 30 or whatever? But we're just going to run a multiplication on that. And I'm going to grab a calculator real quick because I'm not going to try to do that in my head. 1.75 times 17 is 29.75 plus that 4 miles that was just to get in the vehicle, if you might think of it that way. So in this case, y equals $33.75 dollars. And so, no, okay, Clay does not have enough money. Okay, so again, when we're doing this, and I'm going to speak because I'm doing this probably for both honors and regulars, but honors, the expectation for you guys will be that you will identify your variables that are going to be used for your equations on that. So, and I am going to ask that you put it in a form with those variables that make sense to the problem, okay? So just FYI on that. We will talk more about that as we continue, okay? So I'm going to go, let's see, yeah, I'm going to go ahead and do this one. So here's the next one. The Joneses are purchasing a house. The closing cost is $249, so that's a flat fee you're going to pay no matter what. And then it's 3% of the purchase price, okay? So when I look at and identify my, what is what, my y-intercept, okay, if you want to think of it, is 0 to 49. No matter what, it's going to be 249, okay? And then my rate is going to be at 3%. Now, we need to, it's 3% of, okay? So your slope is 0.03, okay? So down here, it says to identify your variables. So if you look at it, the two things that I'm talking about is the purchase price, okay? So given a purchase price, and I'm going to use P for that. How do you want me to write this? Here, I'm going to come over and just go ahead and identify my variables. Okay, so P is the purchase price. And C is going to be the closing costs. So just like what we identified variables earlier. So in this case, the closing cost is $249 plus 3% of the purchase price. Okay? So again, yes, you could flip it around into slope-intercept form, but it is acceptable to put it in this form because that, to me, that makes sense. It's $249 plus 3% of the purchase price. Again, if you're writing it in function notation, it would look like this. Okay? So don't let that panic you if you see at some point in that way. So over here, the purchase price of the home is $195,000. So we're going to come back over here because I didn't put it in here. So when you look at this, guys, this is in y equals m, I'm going to switch it around, b plus mx form. And so your x is your purchase price and your y is your cost. So be sure you keep those in order. So in this case, looking at my point, my purchase price is my x, and I should have made myself more room, and your closing cost is $5,000. Okay? Now, somebody might say, well, what if I flip up the P and the C? What if I just chose to do C and P? Well, that's fine, But again, your equation must follow through that, and it would be a lot harder to do your equation. So this one says the purchase price of their home is $195,000. The seller offered $5,000 in closing cost assistance. Will this cover their closing cost? If not, how much do they need to pay? And so we're going to just try it out and see what we get. So the closing cost is $249 plus 3% of the sell price. Okay? And so again, you can kind of run that through your calculator on there. So 195,000 times 3% is $5,850 plus the $249. So that's $6,099. And so the answer in here is, the question says, will this cover their closing costs? No. And then it says, if not, how much will the Joneses pay? So the Joneses need to pay still the difference, right? Which would be $1,099. Okay? And 100%, you know, that is a lot of how closing cost is figured. It is usually a percentage of some sort, although there's a lot more things in it that is entailed than just a flat 3% on there. But if you ever buy a house, do expect to pay closing costs. So you got to plan that in, and it does get expensive on there. Okay, so there is some examples of how we're going to do some applications, and we're going to go on and do a couple more on the next video.